Okay, so welcome to 8.4. Today we're going to be solving logarithmic and exponential equations. So let's start with a little warm-up just to review some of the things that we've looked at in the past. So we start with 8 to the x equals 16. So this one will involve a bit of a change of base. We know that these are both powers of 2, so 8 can be written as 2 to the 3, and then of course we still have that x there, and 16 can be written as 2 to the 4, and therefore 3x equals 4 because the bases are equivalent, which means the exponents must be as well. So 3x equals 4, and of course divide the 3 off, and x equals 4/3. Log base 3x equals 5, so make your little loop. 3 to the 5 equals x. So what is 3 to the power of 5? 3, 9, 27, 81. 81 times 3 is 243, I believe. So we are looking at x equals 243. Finally over here, make your little loop. X to the 4 equals 625. So basically what to the power of 4 will give you 625, and it turns out that the answer is x equals 5. 5, 25, 125, 625. So there you go. So there's the warm-up. A logarithmic equation, an equation containing the logarithm of a variable, such as x. Exponential equation, an equation that has a variable in an exponent. Okay. So, solve each of these equations. 2 log x equals log 36. Now, we use one of our laws of logs here, and we can put this 2 up as a power of x and rewrite this thing as log x squared equals log 36. Now, since we have a log with the same base, we assume here that it's 10, log base 10. We're taking the logs of both sides. Therefore, the thing we're taking, and if both sides are equivalent, the thing we're taking the logs of must be equivalent as well. Therefore, x squared must be 36, and x must be 6. Now normally we would say plus or minus 6 when we take a square root, but we cannot take the log of negative numbers. Therefore x cannot be negative 6, and we reject the negative answer in this case. Alright, on to the next one. Give myself some space here. 2 times 25 to the x plus 1 equals 250. Now this is going to probably involve a change of base here as well. So let's see what's going on. First thing I would do is divide the 2 off of both sides. So we get 25 to the x plus 1 equals 125. Now, easiest way, in my opinion, recognize both 25 and 125 as powers of 5 and do a change of base. So 25 is 5 squared, and that will be all raised to the power of x plus 1, and 125 is 5 cubed. Alright, now 5 squared to the x plus 1, we multiply the exponents, so we get 5 to the 2x plus 2 equals 5 cubed, and since our bases are equal, the exponents must be equal as well. 2x plus 2 equals 3, 2x equals, and we're subtracting 2 from both sides, so 2x equals 1, and x equals 1/2. So the second method, if we chose to use it, we would start the same way, divide each side by 2 to get rid of that, and then write this as 25 to the x plus 1 equals 125. Now, if we wanted to bring this thing down, we could take the log of both sides here and drop that in front like this, and then write that equivalent. So we've just taken the log of both sides as is, and then this exponent then becomes a multiplicative coefficient. And we now have x log 25 plus 1 times log 25, which of course is just log 25, and that is equal to log 125. And we could subtract this log 25, this one, off to the other side, and we get x log 25 equals log 125 minus log 25. Now when we subtract, we can write them as the log of a quotient, which would be 125 over 25. So we get x log 25 equals log 125 divided by 5, which of course is 5. So let's get rid of this by dividing. X equals log 5 over, this whole thing is over log 25. I'm just going to give myself a little more space here. Log 5 divided by log 25. So x equals log 5. And I'm going to change this 25 into a log 5 squared. Now, since this 2 is an exponent, we can drop it out as a multiplicative coefficient and write x equals log 5 over 2 times log 5. Now you notice that log 5 divided by log 5 will leave us with 1, and our answer 1/2, and we get the exact same answer as we had doing it with the other method. Alright, so let's solve a few of these logarithmic equations just to get some practice with it. Starting with number 1, log base 6 2x minus 1 equals log base 6 11. Now, since we're taking the log with the same base, these things must be equivalent. Okay, so if we basically got rid of the log base 6, then 2x minus 1 must be equivalent to 11. So we simply add 1, 2x equals 12, and then divide by 2, and x equals 6. And that's it for that one. Let's take a look at B. This one's a little trickier. Log of 8x plus 4 equals 1 plus the log of x plus 1. Now, what do we do with this one? Well, I'm going to subtract this log over because these two things have the exact same base. So I'm going to go log of 8x plus 4. So get everything that has a log in it to one side of the equation and see what happens. Okay, so I've moved that over. Now we know that the inverse of a log base 10 is 10 raised to that power. So if we raise both sides of this thing to 10 to that power, 10 to the log base 10 of this, then we basically are just left with whatever we were taking the log of in that power. So we do the same thing to both sides, 10 to that power. Now 10 to the log base 10 would just leave you with 8x plus 4 over x plus 1, and that would equal 10 to the 1, which we know is 10. And then we can go about solving this equation. So multiply that side by x plus 1, and we get 8x plus 4 equals 10x plus 10. So let's subtract 8x, and we get 2x plus 10 equals 4. Let's subtract 10. Subtract 10. So 2x equals negative 6, and x equals negative 3. Okay, on to the next page. Alright, so on to part C here. Log base 2 of x plus 3 squared equals 4. Now, the first thing I would do is I would raise everything to the power of 2. So, 2 to the power of log with a base 2 yields you whatever we were originally taking the log of. And then on the other side, we have 2 raised to the power of 4. So 2 to the power of log base 2 just leaves us with x plus 3, that's a plus, not an r, squared equals 2 to the 4, which is 16. Expand it. X squared plus 6x plus 9, get that by foiling, equals 16. Subtract 16 from both sides. So x squared plus 6x. I don't know what was going on in my brain there. 6x and 9 minus 16 will yield minus 7, and that equals 0. Now this is just simply solving a quadratic. So we can just use our sum and product. So the product must be negative 7, but yield a large positive sum of positive 6. So it has to be plus 7 and minus 1 equals 0. So of course, by your zero product property, x could be minus 7 or x could be positive 1. Now, let's see if both of these situations are possible. And in order to do that, all we have to do is go back up to our original function and plug in each of these values and see if the log is defined. So for minus 7, log base 2 would be minus 7 plus 3 all squared, and minus 7 plus 3 is minus 4, and then you square it and we get log base 2 of 16, which is a possible scenario. So that's okay. So we accept that answer, and then try it with the other one, which is minus 1. So replace that. Minus 1 plus 3 is 2, and we would be taking the log base 2 of 2 squared. And we know that this is possible as well. So both of these answers are completely acceptable. So here's the your turn. Try to go through them on your own, and when you come back, the answers will be waiting for you. So hit pause. So there are your answers. Hopefully I haven't made any mistakes on them this time like yesterday, but we'll just try and forget all about that, I think, now, won't we? Alright, so let's try a few more. A little bit different this time, solving exponential equations using logarithms. So here we start with a. 4 to the power of x equals 605. Now, this one doesn't look simple. It's not one of those really easy ones that we can just do by inspection. So since we can't do it easily by inspection, what we want to do is get this x down from the exponent. Now the way to get the x down is to take the log of both sides. So we get, and we can just use a base 10 log. So log 4 to the x equals log 605. Now, this can come down out in front of the x, and we get log x log 4 equals log 605. And finally, to solve for x, we can just divide both sides by log of 4. Oops. And this is 1, which will just leave x on the left side of this equation. And this we have to do on a calculator. So there you can punch in log 605 into your calculator, and we can divide that by log of 4, and we get around 4.62. So we can just write our answer here. X is roughly 4.62. And we're done. Alright. So let's look at the next one now. 8 times 3 to the 2x equals 568. First thing I want to do, I want to get rid of that 8. So I'm going to divide both sides by 8 so that we're just left with single number to a single power here. So 568 divided by 8, divide this one by 8, and 568. we get 71 on the right side. So 3 to the 2x equals 71. Now again, we want to get that x down from the exponent. So we can take the log of both sides, and then that 2x becomes a multiplicative coefficient, and we have something that looks like this. So 2x equals log 71 divided by log 3. And again, definitely need a calculator for this one. So log 71 equals divided by log 3 equals 3.88. Okay, so 2x equals 3.88. Now divide both sides by 2, and x equals just under 1.9. So something right around there. And that one's done. Alright, so let's do this last one here then. 4 to the 2x minus 1 equals 3 to the x plus 2. So let's just take the log of both sides and let's get those exponents down. This one's going to have a little more to it because we're dealing with binomials in the exponents. So we can bring this down, x plus 2 log of 3. Alright. Now, basically what we have to do is distribute these in, so we get 2x log 4 minus 1 log 4 equals x log 3 plus 2 log 3. Now, since we want to isolate x, we want to group everything with an x in it on one side of the equation. So I'm going to move this log 4 over to the right, and I'm going to move this x log 3 over to the left side of the equal sign. So I get 2x log 4 minus x log 3 equals 2 log 3 plus log 4. Now, since our x's are common over here, we can take out that common x and then just leave this as 2 log 4 minus log 3, and I apologize that I keep writing these as though they're bases, just to force a habit, I guess. And that's equal to 2 log 3 plus log 4. And to get x by itself, we divide both sides by this whole thing here, 2 log 4 minus log 3, so by 2 log 4 minus log 3. So again, you'll need to refer to a calculator for this one. So the first one was 2 log 3. So we go log 3 equals times 2 equals, and then subtract from that, add log 4. We get 1.556. Now we are going to divide that by this whole thing, which is 2 times the log of 4, and then minus the log of 3. And that should do it. And we get right around 2.14. So our answer, of course, that left us with just x. X equals roughly 2.14. And that's done. Okay. Not going to worry about that. So here's another your turn. So give them a try. And when you come back, the answers will be here as always, so hit pause now. And there are your answers, so take a look at those, see how you did. Try them again if you didn't get them. So we'll quickly model this situation using a log function. Paleontologists can estimate the size of a dinosaur from incomplete skeletal remains. For a carnivorous dinosaur, the relationship between the length s in meters, so the length is given an s here, of the skull, and the body mass m in kilograms can be expressed using this equation here. Determine the body mass to the nearest kilogram of an Albertosaurus with a skull length of 0.78 meters. So S is skull length. So basically we have here 3.6022 log of the skull length 0.78 meters equals the log of m minus 3.4444. Yay. Alright, so the first thing I want to try to do, I want to isolate this log m and see if we can simplify here. So we're going to add this minus 3.4444 to the other side, and since everything on the left side is known, we can actually calculate this and get a value for it, and then we'll deal with the rest of it afterward. So let's see what this is going to look like. Log m equals all this junk, so 3.6022. Here we go, 3.6022 times the log of 0.78 equals, and then we will be adding 3.4444, and we get 3.0557 for the left side. 3.0557 equals log base 10 of m. Now, since this is a base 10 log, we can just raise everything to the power of 10. So 10 to the 3.0557 equals 10 to the log base 10 m. 10 to the log base 10 anything is that anything, so that will leave us just with m. So the mass of the dinosaur then is given by this, 10 to the 3.0557, and we go to our trusty calculator for that then, and we say 10 to the power of 3.0557. Thank you, Google. 1136.8. 1136.8 kilograms. All right, there you go. We're going to stop there for today, and I will give you the opportunity to do these next. Oops, do that all the time. This next your turn. So try this one using the same function, and when you come back, I'll have the answers ready for you. So here's the answer. 1.21 meters should be the skull length of that Tyrannosaurus Rex, and I will see you in class tomorrow. Good night.